All right. In this lesson, we will be learning how to solve polynomial equations using the zero product property. One of the things you want to make sure you understand is to use the zero product property, you have to have polynomials that are in factored form, or in other words, a product of polynomials, a bunch of polynomials that are being multiplied together and are equal to zero at the very end. If that happens, then you can construct a new equation where the individual polynomials are all equal to zero. It has a bunch of polynomials that are being multiplied together and are equal to zero. When you have that type of situation, when you have a bunch of polynomials that are equal to zero after being multiplied, you can actually break them apart. You're allowed to break them apart into separate equations and make them all equal to zero. Let me show you an example of a type of problem that actually has that type of situation. In example 1, we have a polynomial. We actually have three polynomials that are being multiplied together. And since they're all being multiplied together and they're equal to zero, we're allowed to use the zero product property to break them apart into their own separate equations that are equal to zero. So for example, I can rewrite this as 2x equals 0. I can write this polynomial as 8x minus 56 equals 0. And I can rewrite this as 4x plus 64 equals 0. And now, when I break them apart, they become linear equations that are easy to solve for x, and then I can determine what was the actual x value that turned the entire polynomial equal to 0. And if you notice here, the x value is 0. X value for this one would be 7, and x is equal to negative 16. Using inverse operations, I was able to reduce that the x value was 0, x equals 7, and x equals negative 16. Now, the challenging questions are going to involve the trinomials that are not in factored form that are equal to 0. What you need to do is rewrite these trinomials into factored form so that you have a product of polynomials that are being multiplied together and equaling to 0. So for this example 2, we're going to try to rewrite the actual trinomial by finding the decomposition terms and then factoring by groups. So the two numbers that multiply to give you 30 and add up to give you negative 17 is a negative 2 and a negative 15. So those two numbers are the decomposition terms for this negative 17, which means we can rewrite this as negative 2x minus 15x, because those two terms, if you add them together, they give that negative 17x. And then we just got to bring down the positive 6 and bring down the 5x squared along with the equal sign and the 0. Now, the next step can be kind of tricky. You want to factor the greatest common factors between the first two terms and the last two terms. Now, the first two terms, the greatest common factor between the first two terms is just the x. And if we do that, we pull out an x from these first two terms, we end up getting just 5x minus 2, because we took away the x's. And then the last two terms, the greatest common factor is a 3. But you want to factor more than just a 3. You want to actually factor out a negative 3, because if you do that, you'll be able to have the same values inside the parentheses, which is what you need to factor by group. So for example, the negative 15x, if we factor out a negative 3, we end up getting a positive 5x. If we factor out a negative 3 from the positive 6, we end up getting a negative 2. And now, since these two, again, binomials are exactly the same, we can factor those by groups. We can take out the 5x minus 2, and left over would be the terms that were about to be distributed, which is the x and the minus 3. And those two form their own set of parentheses, and that would be your factored form. Once you have those two in factored form, you can now use the zero product property to break it apart into two different equations. You can break apart the 5x minus 2 and the x minus 3 and set them equal to 0, because they are in factored form, two polynomials that are being multiplied and equal to 0. And from here, you can now solve for the x values. And in this case, x is equal to 3 and x is equal to 2 over 5.